Imagine managing thousands of cattle across massive ranches without ever building a single fence. No posts, no wire, no sweat, just GPS collars, a smartphone app, and complete control over where every animal goes. This isn't science fiction anymore. It's happening right now, and it's about to revolutionize everything farmers thought they knew about land management. For generations, ranching has been a brutal exercise in physical labor. Farmers wake before dawn, spend their days repairing fences that constantly break, moving livestock across sprawling pastures, or in losing countless hours to tasks that seem never-ending. The work is exhausting, the costs are astronomical, and the inefficiency is staggering. But in the last few years, something extraordinary has begun to shift. Technology has finally caught up to agriculture in ways that promise to fundamentally transform how we produce food on this planet. We're not just talking about incremental improvements here. We're talking about a complete reimagining of livestock management, invisible fences that work across thousands of acres, artificial intelligence systems that recognize individual cows by their faces and detect diseases before a single symptom appears, satellites that watch over farms in real time, monitoring soil moisture, vegetation health, and crop conditions with precision that would have seemed impossible just a decade ago. And smartphones that put all of this power directly into the hands of farmers, allowing them to manage vast operations from anywhere on Earth. This is the story of how agriculture is being transformed. This is about the technology that's already saving farmers millions of dollars, reducing labor dramatically, improving animal welfare, and creating a more sustainable approach to food production. Welcome to the future of farming. It's not coming, it's already here. Let's start with the most dramatic innovation of them all, virtual fencing. For over a century, the physical fence has been the cornerstone of livestock management. Whether you're managing 50 cattle or 50,000, you need fences to keep them contained. These fences require constant maintenance. They break, they need repair, they need to be built and rebuilt. They fail during storms. They create inefficient use of land because you can't easily reconfigure grazing areas. It's a system that has barely evolved since the 19th century. But now, ranchers across North America are discovering that they can eliminate fences entirely. Instead of installing physical barriers, they're using GPS-enabled collars that communicate with satellites to create invisible boundaries. When a cow approaches the virtual fence line, the collar emits an audio. The numbers tell an incredible story about how rapidly this technology is being adopted. Just in the past year alone, ranchers in the United States have created more than 11,000 miles of virtual fencing. That's roughly equivalent to the entire perimeter of the continental United States. These virtual fences represent approximately $220 million in avoided fencing costs. Imagine that. Over $200 million that farmers can invest elsewhere in their operations instead of spending it on posts, wire, and maintenance. 100 ranchers across 22 states from California to the Great Plains. They're expanding rapidly because the system works. Farmers who switch to virtual fencing report dramatically reduced workloads, higher productivity, and most importantly, more time to spend with their families instead of repairing fences. Utilization. One producer who switched to virtual fencing increased their cover crop grazing from 90 days per acre to 170 days per acre. That's nearly double the utilization of the same land. They achieved this simply by being able to move cattle more frequently and with far less effort. This flexibility creates cascading benefits throughout the entire operation. Better grazing management means healthier soil. It means more efficient use of available forage. It means the land itself becomes more productive. Conservation groups are starting to recognize that virtual fencing could be transformative for sustainable land management. Researchers are studying how this technology can help restore sensitive ecosystems by allowing ranchers to graze their cattle in ways that promote ecological recovery rather than degradation. But virtual fencing is just one piece of this technological revolution. The technology extends far beyond managing where cattle are located. Modern livestock operations now have access to systems that can track the health, behavior, and productivity of individual animals in unprecedented detail. These systems use wearable sensors that collect data constantly, analyzing everything from how much a cow is eating and drinking to her body temperature and movement patterns. The sophistication of these monitoring systems represents a fundamental shift in how we understand and manage livestock. For the first time in history, farmers have real-time visibility into the condition of every individual animal in their herd. This capability was completely impossible just a few years ago. Yet today, it's becoming standard on commercial farming operations. Consider what modern dairy operations are doing with machine vision technology. Companies like Canthus have partnered with massive agricultural firms like Cargill to develop systems that use artificial intelligence to recognize individual animals by their facial features and hide patterns. The system watches each cow continuously and records detailed information about their food and water intake, their temperature, and their behavior patterns. This data feeds into decision support systems that help farmers adjust variables like feeding regimens in real time. When a cow shows subtle changes in eating behavior that might indicate illness, the system alerts the farmer. And when a cow's reproductive cycle enters a fertile window, the system notifies the farmer so they can plan breeding. This level of individual animal management was completely impossible just a few years ago. These collars collect data every 20 minutes and can operate for 5 years on a single battery charge. Some systems can detect when a cow is in estrus, when she's ready for breeding, with remarkable accuracy. The technology can reduce breeding gaps by 15 to 20 days, compared to traditional visual detection methods. For large dairy operations, managing hundreds or thousands of animals, this precision adds up to massive improvements in reproductive efficiency and significant cost savings on artificial insemination. Noticeably sick, the system has already detected changes in her breathing patterns and activity levels. The farmer receives an alert and can begin treatment immediately. This proactive approach transforms farm economics. Instead of reactive treatment that often comes too late and costs thousands of dollars per animal, farmers can prevent costly diseases from spreading through the herd. Japan's Tokyo University of Science has taken this monitoring to the next level with an innovative approach that doesn't rely on wearables at all. Researchers developed location-based tracking techniques using multi-camera systems that can track individual dairy cows across an entire barn. The technology uses location information rather than complicated image analysis, making it practical for large-scale implementation. The system enables comprehensive health monitoring, early disease detection, and precise gestation management. As dairy farms grow larger and labor becomes increasingly scarce, these automated monitoring systems are becoming essential to maintaining animal welfare and consistent milk production. Now, let's zoom out and look at the bigger picture. While livestock tracking is getting smarter, the same technological revolution is happening with crop and land management. The view from space is changing agriculture in ways that are just beginning to be fully appreciated. Satellite technology is now capable of monitoring vast agricultural areas in real time, delivering detailed information about field conditions that farmers can act on immediately. This represents a completely different approach to farm management than what existed even a decade ago. Instead of farmers relying on periodic visits to their fields, manual inspections, and guesswork about conditions, they now have continuous oversight from space. They can see exactly what's happening everywhere on their property, anytime they want, from anywhere they happen to be. Modern satellite systems provide multispectral imagery that tracks vegetation health and soil moisture conditions across entire continents. These systems use indices like NDVI, the Normalized Difference Vegetation Index, to measure the health and vigor of crops at different stages of growth. The imagery can be updated daily, giving farmers current information about crop conditions. Drones complement this satellite data, providing higher resolution information about specific areas where problems might be developing. A drone can fly over a field and detect pest infestations or disease presence with remarkable accuracy, allowing farmers to intervene with precise, targeted treatments before problems spread. The integration of satellite data, drone imagery, ground-based sensors, and artificial intelligence is creating an entirely new approach to agriculture. Platforms like Farminaut are building systems that pull together all these data streams into unified dashboards where farmers can see their entire operation at a glance. The platform integrates real-time weather data, soil moisture analysis, and field boundary mapping. It uses artificial intelligence to analyze satellite data and provide actionable recommendations for crop management. A farmer in India can log into their mobile app and see their fields from space, understand soil conditions at the pixel level, and receive AI-generated advisory recommendations about when to irrigate, when to apply fertilizer, and when to expect harvest. The democratization of this technology is particularly significant for small farmers in developing countries who previously had access to almost no management tools beyond their own experience. Now, a smallholder farmer with a basic smartphone can access the same satellite imagery and analytical capabilities that large industrial operations use. This leveling of the technological playing field has potential to transform agricultural productivity across the developing world. This is not futuristic thinking. This is happening right now in 2026. Farmers around the world are using these technologies daily, and the results are remarkable. Precision agriculture enables targeted resource application. Instead of spraying an entire field with pesticide, farmers apply chemicals only to areas where pest pressure actually exists. Instead of flooding an entire field with water, farmers irrigate only the zones that need it. This targeted approach reduces waste dramatically. It minimizes environmental contamination from chemical runoff. It preserves water in regions where water is increasingly scarce. And paradoxically, by using resources more efficiently, farmers often increase yields. The economic implications are staggering. A farmer who implements precision agriculture practices can reduce input costs by 10 to 20%, while simultaneously increasing yields by 5 to 15%. For large operations, this compounds into enormous financial benefits. A 1,000-acre corn or soybean operation might save $50,000 annually on fertilizer and pesticide costs, while producing several $1,000s more in additional yield. Over a decade, that's $500,000 in cost savings plus millions in additional revenue. Consider soil management, which has traditionally been one of the most difficult aspects of farming to optimize. With precision agriculture, farmers can now map soil conditions at the sub-acre level. They understand variations in soil pH, organic matter content, nutrient levels, and moisture holding capacity. This knowledge allows them to practice variable rate application of inputs. A farmer might apply more nitrogen fertilizer to fields with naturally lower nitrogen levels and less to fields that already have adequate nitrogen. This is called site-specific resource application, and it's transforming agricultural economics. Climate change is making precision agriculture increasingly essential. As weather patterns become more unpredictable, farmers need better tools to adapt. Satellite-based soil moisture monitoring has become critical for irrigation planning. In drought years, understanding exactly where your soil still has adequate moisture can mean the difference between survival and bankruptcy. The combination of satellite imagery and artificial intelligence is also enabling something remarkable. Crop insurance and farm financing are being revolutionized. Government agencies and financial institutions are now willing to offer better loan terms and insurance rates to farmers who use verifiable satellite data to document their operations. A farmer who can show satellite evidence of healthy crops, appropriate management practices, and sustainable farming methods represents a lower financial risk. Banks are therefore offering better interest rates to these farmers. This creates a positive feedback loop where technology adoption becomes economically rewarded. Let's talk about the real-world implementation of these technologies on an actual farm. Consider an Australian operation that combines satellite imaging, GPS tracking, and autonomous gate systems to manage cattle across massive rangelands. The ranch spans 10,000 square kilometers, an absolutely enormous area. Historically, managing cattle across such a vast area would require teams of workers, helicopters, and vehicles constantly moving about to check on the herd, consuming enormous amounts of time and fuel, and requiring constant physical presence in remote and often dangerous conditions. Now, the same operation uses GPS collars and satellite technology. Each animal is tracked in real time. The system uses autonomous gates, powered gates that open and close remotely to guide cattle to fresh pasture areas. The animals are weighed in real time using integrated weight systems that measure their condition continuously. The farmer sits in an office or operates from a smartphone and manages the entire operation. This transformation eliminates the need for dangerous helicopter operations, reduces fuel consumption dramatically, and removes workers from hazardous conditions. It's not just about efficiency, it's about fundamentally reshaping how the work of ranching is performed. This example illustrates something crucial. Technology is enabling ranchers to scale operations dramatically without scaling labor proportionally. A ranch that historically required 30 workers to manage might now require 15 or even fewer. Some positions disappear entirely. The work of fence repair becomes unnecessary, as do many of the physical labor roles that dominated agricultural employment for centuries. Other positions transform. Instead of employees spending their days on horseback checking on scattered animals, they're now managing sophisticated software systems, analyzing data, and making strategic decisions. This shift creates challenges, particularly in rural communities where agricultural employment has traditionally been the primary economic driver, and where losing those jobs means economic devastation. But it also creates opportunities that shouldn't be overlooked. The work becomes less physically demanding, and it becomes accessible to people with different physical capabilities or different life circumstances. It becomes year-round instead of seasonal, providing stable employment. And it becomes more intellectually engaging, which appeals to younger people considering agricultural careers. The welfare of the animals themselves is actually improving through these technologies. Virtual fencing allows for more frequent rotation between grazing areas, which means animals get fresher forage more often. They spend less time on overgrazed pastures where parasites accumulate. The continuous monitoring systems detect illness early when treatment is more effective and less traumatic for the animal. The wearable sensors can detect pain or distress that might not be visible to human observers. Cameras in barns can identify individual animals that are being bullied or excluded by the herd, allowing farmers to intervene. These technologies, paradoxically, make large-scale animal agriculture more humane because the constant monitoring allows for better individual animal care. There are legitimate concerns that must be addressed as these technologies spread. Data privacy is emerging as a significant issue. Farmers are understandably concerned about who has access to detailed information about their operations, their herd genetics, their productivity metrics, their land management practices. Some worry about government agencies using this data for regulatory purposes. Others worry about data being shared with competitors or environmental organizations. Currently, There are no clear regulatory frameworks governing data ownership and sharing protocols for agricultural technologies. This represents a genuine problem that must be solved if farmers are going to fully embrace these systems. Technical limitations also remain. GPS accuracy degrades under tree cover, which is problematic for operations in forested regions. Steep terrain can interfere with signal strength. In areas with poor cellular coverage, the systems that rely on constant data transmission struggle. Battery technology is improving, but some systems still require periodic battery replacements. The initial capital investment for these technologies remains high, making adoption more challenging for small and mid-size operations. Halter's virtual fencing collars, for example, represent a significant upfront investment, though the long-term cost savings justify the expense for large operations. Animal behavior adds another layer of complexity. While most cattle adapt to virtual fencing quickly, individual animals sometimes respond differently. Some learn the boundaries within days, others take weeks. A small percentage of animals seem resistant to the training. Each virtual fencing company uses slightly different algorithms for delivering audio and physical stimuli, so effectiveness can vary between systems. Real-world conditions, weather, terrain, herd dynamics affect how well the technology performs. This is why most agricultural technology companies work closely with farmers for extensive on-farm testing before commercial release. The best solutions are those that have been refined through practical experience in actual farming conditions, not just in laboratories. Despite these challenges, adoption is accelerating. The market for virtual fencing alone is projected to grow at a compound annual growth rate of 28% through 2030. This explosive growth is being driven by multiple factors working together. Labor shortages in agriculture are becoming critical. Young people are leaving farming for other industries. Immigration policies are limiting access to seasonal workers. Virtual fencing directly addresses this challenge by reducing labor requirements dramatically. Climate change adaptation is also driving adoption. As weather becomes more unpredictable, the ability to implement flexible grazing strategies becomes increasingly valuable. Regenerative agriculture incentives, government programs that reward farmers for sustainable practices, are providing financial motivation to adopt these technologies. Regional adoption patterns are interesting. North America is leading overall, with the United States and Canada seeing rapid adoption, particularly among large ranching operations. Australia is also ahead of the curve, with agricultural technology companies there having pioneered many of these techniques. Brazil is quickly becoming a major market, as ranchers managing vast cattle operations across the Amazon region recognize that virtual fencing could allow them to graze more efficiently while reducing land pressure. Interestingly, African nations are showing increased interest, particularly for pastoralist communities in arid regions, where the ability to adjust grazing areas quickly could be transformative for managing limited water and forage resources. Looking forward to the next few years, the trajectory is clear. The hardware is becoming more durable, more reliable, and less expensive. Battery technology is improving continuously. Connectivity options are expanding. Satellite internet services like Starlink are bringing reliable connectivity to remote areas that previously had only sporadic cell coverage. Artificial intelligence is becoming more sophisticated at analyzing the massive data streams these systems generate. We can expect increasingly autonomous operations where farmers need to intervene less frequently. We can expect integration across different systems, virtual fencing coordinating with automated gate systems, coordinating with health monitoring systems, all feeding data into unified decision support platforms. Some companies are already working on next-generation solutions. Merck, the pharmaceutical giant, presented new virtual fencing technology at CattleCon 2026, showcasing innovations that extend beyond simple boundary management. The University of Missouri received a $900,000 grant from the National Fish and Wildlife Foundation to fund advanced research on virtual fencing integration with regenerative grazing practices. These investments signal that serious technology companies see genuine long-term potential in these systems. Some researchers argue that precision agriculture combined with sustainable grazing practices could transform vast areas of rangeland and even contribute meaningfully to climate change mitigation. If livestock production becomes dramatically more efficient, producing the same amount of meat and dairy on less land, using fewer inputs and generating smaller environmental footprints, then agriculture's impact on climate and ecosystems could be substantially reduced. This matters because the global demand for agricultural products is increasing. The world population is approaching 9 billion people. People in developing countries are consuming more meat and dairy as their incomes rise. Without technological improvements, meeting this growing demand would require converting vast additional areas to agricultural use. That means clearing forests, draining wetlands, and destroying ecosystems. Precision agriculture offers a pathway to meeting demand without expanding agricultural footprint, by dramatically improving productivity on existing agricultural land. Sustainability goes beyond just environmental metrics. The social sustainability of farming is increasingly challenged. Farmers face declining profit margins despite producing more food than ever before. Young people don't want to enter a profession that demands 60-hour weeks for declining returns year after year. Small family farms are disappearing as they can't compete economically with industrial operations that benefit from economies of scale. Technology offers a potential counterbalance to these destructive trends. If farmers can reduce their labor requirements while increasing their profitability, farming becomes a more attractive career that people actually want to pursue. If technology can help smaller operations compete more effectively, it can help preserve agricultural communities and support rural economies. This isn't just about saving farming as an industry. It's about preserving entire communities and ways of life that have existed for generations. They're operations where the remaining human workers are freed from grueling manual labor to focus on decision-making and problem-solving. A ranch manager sits at a computer monitoring satellite imagery, herd health data, and weather forecasts. She makes strategic decisions about grazing rotation, targeted treatment of sick animals, and resource allocation. This is intellectually engaging work. It's work that pays reasonably well. It's work that can be done regardless of physical ability. Some traditional farmers are skeptical of these changes, and their concerns deserve respect. There's something genuinely valuable in practical, hands-on knowledge of animals and land that can only come from decades of direct lived experience. Computers can fail. Connectivity can be lost. Sensors can malfunction without warning. These technological systems need to be resilient and need to have fail-safes built in. No farmer wants to lose control of their livestock because of a software glitch or a power outage. These are legitimate concerns that responsible technology companies take very seriously indeed. Yet the momentum is clear and accelerating. Every month brings announcements of new capabilities, new companies entering the market, new partnerships between established agricultural equipment manufacturers and technology firms. John Deere, the agricultural equipment giant, is incorporating precision agriculture capabilities into their equipment. Entire conferences like CattleCon are now dominated by discussions of virtual fencing and digital livestock management. University agricultural extension programs are training the next generation of farmers in data-driven agriculture. The transformation is happening at different speeds in different places, but it's undeniably happening. Smallholder farmers in Africa are accessing satellite monitoring through mobile platforms, specifically designed for their circumstances. Large industrial operations in North America are implementing fully autonomous systems. Family ranches in Australia are adopting virtual fencing. Dairy operations in Europe are integrating machine vision and wearable sensors. The specifics vary, but the direction is universal. This technological transformation also raises important questions about the future of rural communities and agricultural economies globally. As productivity per worker increases dramatically, what happens to all the workers whose labor is no longer needed? As capital requirements for technology adoption increase significantly, do small family farms get squeezed out entirely? Can these technologies be made affordable for smallholder farmers in developing countries, or will they benefit only wealthy operations? These are critical policy questions that societies need to grapple with proactively and thoughtfully. There's also the question of resilience. Modern agriculture increasingly depends on electricity, internet connectivity, GPS satellites, and complex software systems. What happens when these systems fail? The 2024 CrowdStrike outage, a single software bug, disrupted operations worldwide and showed how fragile our technological infrastructure can be. Agricultural systems need to be designed with redundancy and fail-safes so that a technical glitch doesn't result in farmers losing control of their livestock or their ability to manage their land. Yet despite these concerns and cautions, the trajectory is remarkably positive. The farmers who are adopting these technologies report genuine improvements in their operations, their profitability, their quality of life, and their environmental stewardship. The animals managed with these systems show improved welfare metrics. The land managed with precision, agriculture shows signs of recovering soil health. The food produced is often of higher quality and higher nutritional density. Technology is removing these constraints. One farmer with sophisticated systems can now manage operations that would have required dozens of workers a generation ago. They can monitor conditions with sensors and satellites that see things human eyes never could. They can access knowledge from thousands of other farmers through data sharing platforms and artificial intelligence systems. This is the future being built. It's not some distant possibility. It's happening right now in 2026 on farms and ranches across the globe. Every cow tracked, every acre watched, every decision data informed. The revolution in agriculture isn't being announced with fanfare. It's happening quietly in the fields and pastures, in the ranches and farms, through the smartphone applications that farmers use every single day. It's a revolution that promises more abundant food, more sustainable production, more prosperous farming communities, and better outcomes for animals and land alike. The future of farming isn't coming, it's already here, and we're only at the beginning.